Alright, so we're starting our new unit on rational functions, but before we get into those types of graphs, we're going to start by kind of reviewing how to read graphs, and today we're really going to focus on end behavior, increasing, decreasing intervals, and finding our max and mins, whether they be absolute or relative. So, end behavior. End behavior requires knowing two things about a polynomial. We need to know our degree, and the degree is the highest exponent when we're given a polynomial like the examples below, okay? Now, when we have a bunch of parentheses in the problem, we're going to have to count up the number of x's we have in the problem, and we'll look at an example of that in a little bit. The second piece of information you need to know is the leading coefficient. Okay, and the leading coefficient is the number attached to the term with the highest exponent. Okay. Now, when we have a parenthesis problem, that's when it's just the number in front. Okay, so kind of two different ways of finding the same thing, but we'll look at an example of both here in a little bit. Alright, so end behavior describes what the graph is doing at its ends. So it's kind of a way of writing out what the arrows are doing. Okay, so all our graphs are going to have arrows, and the end behavior just describes where those arrows are heading. So when we have even degree, I want you to always think about a quadratic, a parabola, whether it's x squared, x to the fourth, x to the sixth, whatever it may be. If it's even, we're thinking parabola, okay? So if I have an even graph and the leading coefficient is positive, okay, so that means I have a parabola that's pointing up. Now, the way we describe end behavior is like this, okay? So if I read that statement, what that's saying is, as x approaches positive infinity, so when I think about my x direction, positive infinity is on the right side of my graph, okay? So on the right side, y is approaching what? So is the graph going up or down? So when I look at my arrows, on the right side, it's going up to positive infinity. The second piece is figuring out what's going on the left side of the graph. So as x approaches negative infinity, which is my left side, y is approaching, again, arrows pointing up, so positive infinity. Alright, so if it's negative and even, that means my parabola would be facing down. So as x approaches positive infinity, y would be going down to negative infinity. As x approaches negative infinity, which is the left side, y would be approaching negative infinity as well. Right? Now, if I have an odd polynomial, so x, x to the third, x to the fifth, so on and so on, I want to always think about my cubic function. So if my leading coefficient is positive, and I think about x to the third, that is this graph here. So on the right side, my arrow is pointing up to positive infinity. On the left side, it's pointing down to negative infinity. If I have a negative coefficient, it's going to flip that graph, so that'll look like this. On the right side, it's going down to negative infinity. On the right side, it's going up to positive infinity. So, takeaway here, if it is an even function, my end behaviors are going to be going in the same direction. If it's odd, they're going to be going in opposite directions. Okay. So let's look at some examples here. For the first problem, I always like to circle whatever term has the largest exponent, because that's where I get all of my information from. So 5x to the third. That tells me that my degree is odd, right? Third power. And my leading coefficient is 5, which is positive. So odd and positive looks like this. So as x approaches positive infinity, right side, my graph is going up to positive infinity. As x approaches negative infinity, left side, my graph is going down to negative infinity. All right, number 2, here is my largest exponent. It is x squared, so it's even, and my leading coefficient, the number in front of that, is positive 1, so it's even and positive. So parabola pointing upwards. So same direction on both sides. So on the right side it's going up, and on the left side it's going up as well to positive infinity. Number 3, there's my largest exponent. Degree would be even. Beginning coefficient this time is negative 1, so it's even and negative. Again, think about your parabola. So a negative parabola would be pointing down. So right side of the graph is going down to negative infinity. Same with the left side, going down to negative infinity. All right, last problem here. There's my largest exponent. So my degree is odd. And my leading coefficient is negative 1 again, so negative. So that's going to be the cubic function that looks like this. All right, so right side of the graph, it's going down to negative infinity. Left side of the graph, it is going up to positive infinity. So that's end behavior. Now, let's look at sketching a graph using that information. So it gives me a polynomial that's broken down into its factors. Okay, now those factors tell me my zeros. The one thing you need to note here, though, is the degree on each parenthesis. So if the degree on the parenthesis is an even number, that means that at that 0, it is going to bounce. Okay, it's not going to cross the x-axis there, it's just going to bounce at that point. If the exponent on the parenthesis is odd, that's when I cross. Okay, so first we're going to figure out the degree and the leading coefficient to figure out our end behaviors. Then we're going to find our zeros, and then we're going to look at our bouncing and crossing and connect all of that information. So first things first, to find the degree. So this is one of those problems that have parentheses in it. So the way we handle it, I like to use dots, but you don't have to. So if I look at the first term there, x squared, that means that I have 2 x's, so I'm going to put 2 dots down below. Then I have the parenthesis x plus 2. X plus 2 to the first power, right? So that means that there's 1 x plus 2. So that's going to give me 1 more x. Then I have x plus 1 to the 4th. That means I have 4 x plus 1s in the problem. So that's going to give me 4 more x's, so 4 more dots. Lastly, x minus 4 to the 3rd means that there's 3 x minus 4s, so 1, 2, 3. So to figure out my degree, I'm going to count up all those dots. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which means even. All right, now I need to figure out my leading coefficient. So again, when I have parentheses like this, your leading coefficient is the very first number there. So here it's negative 1. So that means that I have even and negative. So my leading coefficient is negative, my degree is even. That means both arrows are going to be going down. If I think about my quadratic, right, it'd be a parabola facing down. So I'm going to start by drawing my xy plane here. All right, and I like to put arrows in the corners so I know where my graph has to eventually go. So left side it's going down, right side it's going down. Okay, now my zeros. If I set each term or each piece equal to 0, we would have negative x squared equaling 0. Solving for x, that gives me 0. X plus 2 equal to 0, that would give me negative 2. X plus 1 equaling 0, that would give me negative 1. And then the last piece would give me positive 4. So let's go ahead and put those dots there. So -1, -2, and 4. So -2, -1, 0, and 4. Now, I want to look at my degree. Again, even means it's going to bounce off the x-axis. Odd means it crosses. So, for the 0, right, that's x squared. So this is going to bounce. Okay. So we have a bounce at 0. When I look at x plus 2, that's x plus 2 to the first. Odd, so that means it's going to cross. -1, that's x plus 1 to the fourth, so that's going to bounce. And then x minus 4 to the third, that means it crosses. So crosses, crosses at the -2 and the 4. Now, the -1 and 0, we're going to have a bounce, but I don't know what side that the bounce is going to happen until I start doing my drawing here. So I'm going to start on the left side and go to the right side. I know it has to start down, right? So I'm going to start down here. I'm going to cross the -2, bounce at the -1, bounce at the 0, and then cross at the 4 and finish going down. And there's my quick sketch. It doesn't matter how high you go for your turns, right? The maxes and mins, that doesn't matter when we're sketching. When we get later in this lesson, we're going to use the calculator to help us figure out those max and mins to make our graph a little bit more accurate. Alright, let's look at B. So if you want to try this one on your own first, go ahead and pause the video and try it. But here we go on that one. So again, find the degree first. So x plus 4 squared, that's going to be 2. And then x plus 1 to the third, 1, 2, 3. So that gives me a degree of 5. So we are odd. Number in front, -1. So my leading coefficient is negative. So we're odd and negative. So thinking about my cubic function, that's going to look like this for my end behaviors. So drawing our graph here. Again, I'm going to start by putting where my arrows end. So left side is going to be going up, right side is going to be going down. Now I want to find my zeros. So x plus 4 equaling 0 is going to give me -4. X plus 1 equals 0 is going to give me -1. So 1, 2, 3, 4. Go ahead and graph those. Here's -1. Alright, so now I just need to figure out my bounces and my crosses. So -4 is x plus 4 squared. So that's going to bounce that -4. X plus 1 to the third, so it's going to cross at -1. So I know I have to start at the top, and it's going to bounce at the -4. So the way I handle that, I'm just going to start with this arrow. We're going to bounce, and then cross, and finish going down. Try to round that out a little bit. So not the prettiest graph, but again, it doesn't matter the height of that peak there. Right, we're just sketching. The main things that matter, you have the right zeros and your right end behavior, and then whether it bounces or crosses. All right? Now, let's look at going the other way. So it gives me a graph, and now it asks me to create an equation. So, now, these should have arrows on it. So go ahead and draw those on if you're using the notes there. First thing I want to identify are my x-intercepts. So I have x-intercepts at -8, -5, 1, and 4. Now that I have those x-intercepts, I want to see what crosses and what bounces. So -8, we cross. Then -5, we bounce. Cross at the 1, and then bounce at the 4. Now, I want to see what's going on with my end behavior here. Okay, so looking at my arrows here, they're both going in the same direction. Same direction means that it has to be even. Okay. Now they're both facing up, so that means it has to be even, and my leading coefficient has to be positive. Alright, so let's go ahead and write our x-intercepts as their factors. So I would have y equals, I'm going to have x plus 8, right? It's going to be the opposite sign. X plus 5, x minus 1, and x minus 4. Now I just need to adjust the exponents so that things are even if they bounce, odd if they cross, and that everything adds up to give me an even total, because my degree has to be even. There's a bunch of different answers you could have here. Okay, there's no set like what exponents go where. As long as the evens go with the bounces and the odds go with the crosses, we're good. Okay, so the negative 8 crosses, so that has to be odd. And I'm going to leave that as 1, so I'm not going to put anything there. Now the x plus 5, that bounces, so that it has to be even. So I'm going to try and go with a 2. Let's see if that'll work. Then we have the x minus 1. It crosses, so that's going to be even. So let's leave that as 1 again. See if that'll give us our total here. And then the x minus 4, again, bounces, so that has to be even, so let's try 2 again. Okay, so add up all of your exponents together, so we'd have 1, 2, 3, 4, 5, 6. So that's one possible answer. Okay, my total is even, the leading coefficient, the number up front is positive 1, and I have my bounces and my crosses correct. Now another example just to show you. You could have had something like this. Okay, so we have the x plus 8, x plus 5 has to be even, so you could have said something like 10. Then we have the x minus 1 has to be odd. You could pick anything, so 73, why not? And then the x minus 4 has to be even again, so we could say something like 8. So you just have to add everything up to make sure you have an even number at the end. So 1 plus 10 is 11, plus 73 is 84, plus 8 would give me 92. So I'm still even, still positive up front, so we're still good. Okay? All right. Now let's look at max and mins and increasing and decreasing. This will be somewhat of a review, so I'm going to go a little bit quicker here. Okay? Again, the difference between absolute and relative. Absolute max and mins are the absolute highest value or the absolute lowest value that the function can assume. Okay? So that's the highest y value or the lowest y value. That can include like your highest peak, your lowest valley, or it could be an endpoint depending on what our graph looks like. Now, relative is just everything in between. Okay, a lot of times we'll have relative if it's odd because our arrows are going to go up forever and down forever, so there's not going to be an absolute max and min, but there will be some relative max and mins in there. But they still represent your high points and your low points. Okay, so think your peaks and your valleys. So looking at number 5. Max, absolute min. So I see that I have my arrows going up forever. So because they're going up forever, it's not going to have an absolute highest point. It's going to keep going up and up forever. So our absolute max, we wouldn't have one. So we would just say none. However, since my endpoints are both going up on both sides, that means that there is a lowest point. So the lowest point I can see here is this point right here. And if I count that out, that's the ordered pair -4, -3. Now again, relative max and relative mins are all your peaks and valleys in between, but it also includes your absolutes. Okay? So absolute maximum would be this guy right here. That's the ordered pair 1, 2. Relative min are just all my valleys, all of them, including this guy. So we would have that point and that point. So we have the ordered pair -4, -3, and the ordered pair 3, -1. Now, increasing and decreasing, we've done this earlier in the year, but to kind of refresh our memories, I'm going to do this example in more detail, and then when we get to the later examples, I'll go a little bit quicker. So I'll kind of color coordinate it for us too. But starting on the left side, I am decreasing until I get to this value. Now, it's important to remember with increasing and decreasing, we always use the x values of the interval. And that's what makes this confusing, because when you think about increasing and decreasing, you're looking at the graph as things move up and down. So you want to use y values because you're thinking up and down. But you always want to bring that interval to your x-axis and use the x values to describe that interval. So I'm going to bring this up to the x-axis. So from here and everything to the left, I am decreasing. So all the way out to the left, we have -infinity, and then it stops at 1, 2, 3, -4. So I'm decreasing from -infinity to -4 on the x-axis. Now, as I continue moving, I'm going to be increasing from here to here. So again, bring it to the x-axis. So from -4 to 1, I am increasing. So -4 to 1, continuing, I start to decrease from here to here. So that is from 1 to 3. And then to finish it up, from here and everything to the right, so to positive infinity, I am increasing. So that would be from 3 to infinity. Now, a way to check that you have all your increasing and decreasing intervals, you can get from -infinity, so the left side of the graph, to positive infinity, the right side of the graph, without any gaps. So if I look here, I go -infinity to -4, and then -4 to 1, then 1 to 3, and then 3 to infinity. So there's no gaps, I got them all. All right? So next example, again, I'm going to go a little bit quicker here. If I look at my end behaviors, I have one arrow going up and one arrow going down. So this thing's going to go up forever and down forever. So will this have any absolute max or mins? No, because it's going to increase forever and it's going to decrease forever. So we would have none and none for my absolutes, but there are relative max and mins. So here would be my relative max, and that's the ordered pair -4, 3. And then here is my relative min, which is the ordered pair 1, -3. Now, increasing and decreasing intervals, again, I'm going to go a little bit quicker here. Right side of my graph, I'm going up, so I'm increasing, and that's from -infinity to 1, 2, 3, -4. And I'm decreasing from here to here, so that's -4 to 1. And then increasing here and then to the right to positive infinity. So increasing from 1 to infinity. All right. Again, you can check -infinity to -4, then -4 to 1, and then 1 to infinity. So I'm good. All right. All right. Next example here, this one's a little bit trickier because it has that break in the graph. Okay, so my first question is, and this is just thinking back to our first units, is this a function? Answer to that is yes. Okay, just because it has a break in the graph doesn't mean it's not a function. It's still going to pass that vertical line test. And the only place you would really need to check is right here, where these 2 points kind of overlap. Because one of them's open and one of them's closed, there isn't 2 points there. There's the closed point here, and then that open dot represents that there's nothing there. Okay, that's just where the jump happens. So this would be a function. Now, if this was a closed dot at the top and a closed dot at the bottom, then it would not be a function because it would have 2 dots on that same vertical line. But that's just a little side note for us there. Erase that stuff. So, absolute max, absolute mins. Now, this has arrows going down and down. So normally that would make me think, okay, this is going to have an absolute high point. But the issue is this closed dot. Okay, so there's no absolute maximum because we can keep getting closer and closer and closer to that dot. So if I were to try and say that 1, 2, 3, 4, 5, 6, 7 was the absolute maximum, right? Well, there's really not a dot at 7. So then I would think, okay, well, what about 6.9? But then I could say, well, there's 6.91. Or 6.92, 6.99, 6.99999, forever and ever and ever, right? So we can keep going up and up closer and closer to 7 without actually ever getting there. So there is no absolute maximum because of that. Arrows are going down to negative infinity, so there's no absolute min. But there are relative max and relative mins, okay? So my relative max would be this right here, okay? And that would be the ordered pair negative 3, 5. Now, my relative min, and this is a little bit different, my relative min is going to be this endpoint here. Remember, it's just the low points on an interval, right? So the low point for that left section of my graph would be that endpoint, that closed dot, which would be the ordered pair negative 1, 3. All right? Increasing and decreasing, again, real quick. I'm increasing on the left side to here. Okay, so that's from negative infinity to negative 3. And then I am decreasing from here to here. So that is from negative 3 to negative 1. And then I am decreasing here, but I've already taken care of that part. So I just need to pick up my graph from the negative 1 over to the positive infinity. I don't need to, yeah, okay? So negative 1 to infinity would close that out. Because there's that break in the graph, you can't just say it's decreasing from negative 3 to infinity. Okay, you have to include that break when you're writing your interval for the decreasing part here. Okay. All right, now we're going to look at using the calculator to figure all this stuff out. I do have Desmos loaded up, so hopefully this will work. So I'm going to go to Desmos here. I think it's a little bit glitchy though, so bear with me. And we're going to graph 3x to the 4th minus 4x to the 3rd. Alright, so there is my graph. Let me zoom in a little bit. So, things I need to look at. Maxes and mins, and increasing and decreasing intervals. So, first things first, let's find our maxes and our mins. So, this thing is going up and up, right? It's even, it's positive. So, I'm not going to have an absolute max. It's going to increase forever. Now, I do have an absolute low point, right? So my absolute minimum would be this point right here. And that's the ordered pair, 1, negative 1. All right, so let's go ahead and write that information down. So just to kind of give us a quick sketch here. And down. And back up like that. All right, so absolute min was here, and that was the ordered pair 1, negative 1. Because it's going up on both sides of my graph, there's no absolute max. Now, there is no relative max. There's no peak in this situation. So there would be no relative max. My relative min, again, is just going to be the same as my absolute min. So we're just going to copy that down. 1, negative 1. Now, let's go back to the graph to look at my increasing and decreasing intervals. All right, so starting on the left side, so from negative infinity, if I follow this down, I'm decreasing, still decreasing, until I get to that absolute minimum. So from negative infinity to 1, I'm decreasing. And then from 1 to positive infinity, I am increasing. So let's write that in. So from negative infinity to 1, I'm increasing. And then from 1 to infinity, or sorry, I said that backwards. From 1 to infinity, I am increasing. From negative infinity to 1, I'm decreasing. All right. All right, again, we're going to have to graph this. Okay, so let's go back to Desmos. I'm going to erase that one. And now we're graphing x to the third minus 8x plus 3. Let's zoom that out a little bit so we can see better what's going on. All right. So this thing's odd, right? X to the third power. And it's positive. So if I think about my normal cubic function, on the right side it should be going up, left side it should be going down, which we have here. Okay. Now, because it's going up forever and down forever, we're not going to have any absolute max or mins. But this does have a relative max right here. Okay. So negative 1.63 and 11.7, we'll say. And then we have our absolute or relative minimum at this point right here. So 1.63, negative 5.7. So let's go and write that information in. All right, again, just to draw kind of a rough sketch of what we got going on here. Looks something like that. Okay, so no absolute max, no absolute min. My relative max we said was negative 1.63, 11.7. My relative min was 1.63, negative 5.7. Now, increasing and decreasing. If I think about where my max and mins are, right, so that's kind of what splits up my increasing and decreasing intervals. Here would be the x value, negative 1.63, and then here would be the minimum, which would have the x value of 1.63. So if you want, you can flip back to the graph. I'm going to do it from here, though. So starting on the left side, I'm increasing on the left side to negative 1.63. So negative infinity to negative 1.63. And then I'm decreasing from negative 1.63 to 1.63. And then increasing 1.63 to positive infinity. All right. last example real quick. Again, we're going to have to go to Desmos here. So, before we even go to Desmos though, let's see if we can answer some of this stuff before looking at the graph. So, my degree is even, leading coefficient, negative. And it's x squared, so this is going to be a parabola, and it's going to be facing down. So this will have an absolute max. I don't know what that point is. I'm going to get that from the graph. But I know it's not going to have an absolute minimum. None. And again, because it is a parabola, right, it's x squared, it's not going to have a relative minimum either. So now we're going to use Desmos to figure out where that absolute max is. So let's erase that one. We have negative x squared minus 4x minus 1. Change my graph up a little bit so I can see. Alright, that absolute maximum happens right there. And that's at the ordered pair, negative 2, 3. Okay, so left side of negative 2, we're increasing, right side, decreasing. So absolute maximum, negative 2, 3. That's also my relative maximum. Right, so if I think about the graph, here's negative 2. That's where that maximum point is. There's 3. So it looks something like that. So increasing from negative 2 all the way to the left. So increasing from negative infinity to negative 2, and then decreasing on the right side. So negative 2 to infinity. All right, that is it.